So session 2 on zero pollution in soil, air, and water. So it's going to be shared by Claudia Cosio from the laboratory CBio at the University of Reims, and as well Stéphanie Sayen, that is as well associate professor at the laboratory, the Institute, the Molecular Chemistry Institute of Reims. So, thank you very much.
Thank you, Hélène, for the introduction. So the topic of this morning will deal with chemical pollution, and I will start with a few numbers. So there are about 350,000 different types of manufactured chemical on the market today, and we are still dealing with legacy pollution, so molecules that are not in use anymore. The production of chemical has been multiplied by 50 in 50 years. Plastic production has increased by 79% in 15 years. And it's estimated now, currently, that the total mass of plastic on the planet is more than twice the mass of living animals. And plastic contains 10,000 other chemicals. So last year, in 2022, beginning of the year, it was officially announced that we crossed the planetary boundary of chemical pollution. Its official name is Introduction of Novel Entities into the Biosphere, but it concerns chemical pollution. And crossing the boundaries is identified as a threat to the stability of the world, and it is a very serious problem. In fact, we are currently all breathing microplastics that are in the air. This pollution is linked to about 10% of premature deaths in European currently. And there are overwhelming evidence of the importance of avoiding the pollution. And as explained yesterday, we need an holistic approach. We cannot find solution in monodiscipline. And this is the vision of the zero pollution concept that aims to respect the planetary boundaries of our planet by 2050. And it's not zero pollution, it's a toxic-free environment. So the session of today will be introduced by Stéphanie.
Thank you, Claudia, for introducing the context. So good morning, everybody. We would like to welcome you to the session Zero Pollution in Air, Soil and Water, a session dedicated to contamination, which can be present in these different environmental compartments and in contact of living organisms. As you know, this contamination may have adverse effect on these organisms and on human health. Without going as far as zero pollution, which is utopian, if we want to mitigate this pollution, it is necessary to study and understand the behavior, fate, and impact of contaminants to modelize and assess their risk and regulate them to preserve the ecosystem health, the food safety, and of course the human health. And it needs to conduct not only pluridisciplinary and interdisciplinary research, but also transdisciplinary research toward socio-ecological system approach. So this morning we will have 4 presentations addressing different aspects of this issue and specific needs. So we would like to say a special welcome to our 4 speakers, Thomas Lauvaux, Gwenaëlle Imfeld, Guillaume Jubot, and Anthony Lehmann. And we are going to start this session with a presentation dedicated to the atmospheric part, the atmospheric compartment, by Thomas Lauvaux, who is a chair professor at the University of Reims Champagne-Ardenne in the atmospheric and molecular spectroscopy group, a joint research unit between our university and the CNRS. Thomas is specialized in climate sciences and develops monitoring systems based on atmospheric data. So he is going to present a joint approach to air quality and carbon monitoring dedicated to support mitigation at city scales. So, Thomas, the floor is yours.
Hello, everyone. Glad to be here. SNCFs tried to stop me, but they didn't do it. So I'm here, tired, but here. Okay, here we go. My slides are in French. I'm sorry, I was not sure what was the official language of that conference, so where do I go? Here? Here? N'importe où. Yeah. Okay. So that's a view of Chongqing. If you have ever visited in China, 45 million people. And that's going to be the topic of my talk today, these very, very large metropolitan areas where a lot of action is happening. Little background, because it's always good to remember what's driving today climate change and the increase in a lot of pollutants we have in the atmosphere. On the top part, you see the emitters, the sources, right? So burning fossil fuel right here in gray, and you can see how we've been doing a great job at that. Land use change, which has been fairly stable. Some places gets deforested, some gets regrown, for example, in North America or other places in Europe. And the sinks. Thanks to the sinks, we only see half of the emissions we have on the planet. A quarter is getting into the vegetation. You see that very, very large variability. And another quarter goes into the ocean, right? So we're left with half of what we emitted, which is a good news, right? Because otherwise the pace of climate change will be twice as fast as we observe today. Oh, sensitive. Okay, just a quick picture. You can look at that in many different ways. You can look at the global emissions. We're all contributing to that. We're more than 10 petagram of carbon today emitted every year. You can look at that by country, and you can do the blame game, as we call it, where you can pick your country and just say who is the bad player and the good player. And you can see here, yeah, the rapid change of that. This is maybe the most biased view ever, because you don't know who is producing for who. You don't know the import, the export. You just know at the national scale what is happening. So it's a very good image if you are in the EU and your industries have been moved out. Well, it's bad news for China if you export 80% of what you produce, right? So then you can do a different kind of look. You can say per capita, right? We have a lot of discussions like that. It's the USA, but it's not the top country in the world. No, top countries in the world are in the Middle East, the Arabian Peninsula, and Canada. I don't like to say that, but it's Canada. It's very cold, and so it's like an American person, but in a very cold country. And then you have the other players, and then you see that China completely shifts. Now it's not the key player in the game. They're doing pretty well per capita. And you can look at this energy type, and we always have to remember that. We talk a lot about our energy use. The main source of energy right now, fossil fuel, is coal. We have a lot of coal, a lot of coal that we dig every day out of the ground. So we need to keep that in mind. We talk a lot about oil. More recently, we talk a lot about gas. You heard about fracking, maybe, the liquefied gas that now we ship and export everywhere around the world. This production has been expanding really rapidly in the last decade. So gas is becoming a major player as potentially a transition fuel, as they call it. Is it really a transition fuel? I'm not sure about that, but it's not the topic for today. Okay, so what's the link between pollution, finally, and carbon emissions? Well, I'm going to take an example. This is actually emissions over China from NOx, so emitted by cars and the combustion of fossil fuel, right? And any combustion chambers actually would produce some level of NOx. And you can directly relate these links. Yeah, as soon as we emit carbon, we also have all the co-emitted species that are oxidative species. They are reactive species in the atmosphere. CO2 tends to stay forever. NOx doesn't. NOx disappears quite fast. There is an oxidation process, and it disappears in the atmosphere. It takes other forms, right? The link is quite obvious. Well, but in reality, we don't link them. And a lot of the climate policy that we do for CO2 have nothing to relate to the air quality policies that we drive. I'm going to take this example in France right now as we just put policies on cars and emission regulations. In no way in that law we talk about carbon emissions. Well, diesel engines, for example, are going to be banned sooner or later. They're the most fuel efficient from far in terms of CO2. So we expect an increase, technically, in carbon, unless we go massively into electrification. So keep that in mind, that these two, quite obvious, yeah, obviously they are related, but they are not in the policies we design today. If you go at the country scale, so here you have the pollutants emitted, this is measured by satellite, and you have the CO2 emissions related to that. Well, it depends, what is your country's economy? Is it more an industrial country? Is it more a service-driven economy? And you can absolutely link the activities right now in Bangladesh and India, most European countries being negative in pollution and negative in CO2. And some countries, for example, Canada, stand out as a positive in the pollutants. Well, the fracking, the gas industry has been massive, and so the air quality degraded in the last 5 years. So this is how you see these surprising trends that are linked with the different activities you decide to grow in your own economy. China had a very aggressive policy since 2014 on the pollution, but none on carbon. So you have a very positive gradient every year in China for carbon, and you have a negative trend in pollution. And you have these new economies growing, and you see the strong economies now, also from sub-Saharan Africa, where you have a lot of countries growing very fast, strong economies, with heavy pollution, because you're still in an industrial economy, so you release a lot of aerosols and contaminants. Okay. Overall, if you look at where these emissions take place, it's a very, very small fraction of the total. About 2% of the globe, where you concentrate most of the emissions in the world. Because it looks like that. It's dark everywhere, except these hotspots that you have on the map. Less than 2%. About 70%, I don't like that number, but let's say more than half of the global carbon emissions come from these large metropolitan areas. It's where you concentrate the population, your industries, your services, your power plants, your shipping. So they are massively concentrated, little tiny fraction of the land that actually emit the majority of our emissions at the global scale. So you cannot do this kind of coarse global analysis. No, you need to look at these very false hotspots on the map, because the rest of the world is actually a blind spot. There is no emissions in 80% of France, for example. Okay, so cities have started to just play a role, and as nations have kind of slowed down and not getting to the level that we expected, cities decided to play their own game, on their own, to say we can drive the problem because we are 70% off the problem. Okay, cities got together and organized into very large consortiums, international consortiums, and you're going to find several of them. The C40 megacity, the Covenant of Mayors, and they had organizations around them to help them draft what they could do, how they could act, how could they decrease their emissions. This is very carbon-driven. It's not pollution-driven. We're not talking much here about how you're going to contaminate your local people. No, we're really talking about decreasing in terms of carbon-related energy, decreasing your demand. These consortiums do not always agree. Their protocols are different, their networks are different. So for example, if you go through Europe, Paris might be in the C40, but Munich next door is not. So meaning they have different objectives that they have drafted. Typical objectives, example is Paris here. They go on IPCC reports and they look at what the global objectives are and they stick to that. That's the goal. So we say we're carbon neutral by 2050. Carbon neutral. Always remember, it means that you're neutral, you're not zero. Nobody said Paris will be zero emissions by 2050. No, people said whatever is left, and we still have to emit because there's nothing we can do about it, will compensate. Okay, that's actually a very dangerous game, right? If all the cities in the world start to have a big plan for compensation, there's going to be a lack of carbon stocks at one point. So we have to be very careful what it means to be carbon neutral. When you see these zero target emission 2050, always keep in mind that it could mean you do absolutely nothing and you buy a giant forest in Tanzania. So keep that in mind. This is really the objective of the city. Okay. Okay, problem with that. When you do an inventory, when you start to say, what are my emissions, you go to talk to your local expert and they start to add up numbers. You count how many cars, how many people live, what kind of heating systems they have, how much gas they use, oil they use, renewable energy as well. They burn their waste. They also clean their water. All these are sources. You end up with thousands and thousands of little sources that you have to add up to come up to a total. Problem, well, they don't agree on the way to count them. they often don't know how to translate them. If I tell you I counted in Reims yesterday 20,000 cars on that road, you don't know which car, you don't know how old they are. So it's very difficult to make a budget. So these end up with very large mismatches. Why mismatches? Because of protocols also. We don't agree on the way to count that. This is a historical kind of timeline of what happened over the years. You start with the very early on, GHP, some protocols were drafted and they were improved over time. And organizations proposed to work on that. So they proposed to you the protocol to follow. More organizations, more protocols, larger uncertainties. It's nearly impossible to compare two cities today and really see which one is doing best. How is really their emissions going? We don't really know. So that's the key problem, because if you're 70% of the world emissions, you want to tackle climate change, but you don't even know where you are today, good luck. This is what happened when we took the inventories of 50 cities across North America, and we did a very careful assessment of their carbon budgets. And it was quite scary. On average, they are 20 to 30% lower, than what they are for real. Meaning we already start 20% below what we really do. So when they think they decreased by 30%, they just caught up with the numbers they had in store. It's even worse. Some cities go to 100%, 100%. Miami, the city of Miami, declared zero energy from electricity bought by the city. Zero, none. So these kind of numbers are scary. And when you look at all these, this is what makes up for most political decisions. That's why the next policymakers are going to use to draft their policy over the coming 30 years. So you imagine, how do you expect your climate change, your climate action plan, based on numbers that might be completely underestimated or absolutely misattributed? You draft your policy and you are very unlikely to get to the objective that you settled at the very beginning. Okay, so how can we do better? And there are solutions. I'm going to show you one. There are others, but this is one that we have done for air quality. When you do air quality, nobody is asking you, where is your total pollutant inventory? No, you go on the website and you look at the concentrations. It's kind of funny because, well, we're talking about emitting pollutants and you measure in the air because that's what concerns you. You breathe the air. Well, carbon is exactly the same, except you cannot see it and you cannot smell it. But it's all around us, it's everywhere. So you can do the exact same approach we've done for air quality. You deploy a lot of stations around your city, and you run, exactly as they've done for air quality, a transport model. You run like a weather forecast every day, and you combine that with your favorite inventory, and you create what you're supposed to see. You compare that to what you actually did see, and the mismatch tells you how wrong you were in that very first estimate. So we can double check what the cities are doing. That's pretty much what it says. Other advantage, the latest inventory for Paris dates from 2018. So the mayor of Paris today, Hidalgo, is making plans for the future. The latest number is from 2018. We're in 2023, and she's drafting something for 2030 on a number that might be 30% underestimated. So imagine if you were today the policymaker and you had to take that decision and spend millions of euros on a project you're not even sure will ever work. So don't blame them for what they do, just realize that they rely on very little information to this day. Okay, I'm going to take an example because for us was a test of the system. The confinement, mobility restrictions were massive, the city was shut down. These pictures are from another world, another time. We try all to forget, but we still grieve that really strange time that is still affecting us today, right? So we decided to measure, and we thought, fantastic exercise. The city was dead quiet. So we're gonna see that enormous drop, and we can see if our system is able to catch that. If we can, it's a good sign. It means we can really see the day-to-day variability. So this is Paris in 2018 in terms of CO2 emissions. For those of you who have been through Paris, you see it's a very large metropolitan areas with major highways crossing the place. 2019, kind of similar year, and 2020. If you look at by sectors, so the building sector, the energy you use to heat up your buildings and turn on the light, the traffic emissions on the other, yes, there was a massive drop in the traffic emissions, for sure. Well, we stayed in the building, so the stores shut down, but we actually did stay in a house. So we use a lot of electricity, more than usual. We use also a lot of oil and gas in the burners. So we didn't play really much of a big role on our local emissions. And finally, the others. These are the industries that for the first confinement, we shut down. We shut down a lot of our industrial production. On the second confinement, well, we kept the schools open. And the industries were allowed to keep going because the economy was really affected by all that. And you see how, yeah, the emissions actually decreased much less. So we checked that with our system. No. Yes, suspense. Here we go. Okay. No, okay. So what you do is you cut Paris into pieces, like that. We have intra-Paris, suburbs of Paris, and then the whole region of Ile-de-France. Well, why do we do that? Because the mayor of Paris only decides on that little red spot in the middle. 2.5 million people among 13 millions. So it's a very complex thing as well. We have to remember governance. Mayors don't decide on whole Paris. No one is in charge of the entire metropolitan area. You can only control that little chunk in the middle of this giant metropolitan place. So we checked and we found this decrease. About 40% for the first confinement and only 20% for the second confinement. 40% decrease. I mean, you remember, there was nothing around. Wherever you were on the globe, you had that very short time when it was panic and we all just stopped living. 40%. The 2030 objective is 50%. So I tell you right away, if you just stop living right now, it's not enough. It tells you the magnitude of the change that we have to put in place. The second restriction, which was also pretty strict, you couldn't go around, you couldn't travel, you just had to do to the essential businesses, school activities, was 20%. It shows you how the systemic problem we have. Our energy system is made so that just living, eating, breathing, will get 60% of the total emissions of your area. So it shows you it's a very disruptive change that we have to put in place. It's not only, I avoided to take my car this morning, I took my bike, whoo, planet is safe. It's not enough. It's just not enough. Because you had food in the morning, and where your food is coming from, well, that's 60% of your total. The energy of your house, your water heater, etc., etc., etc. That number is really key, and this is what we were very surprised, because we thought the emissions would drop by 80 or 90%. Absolutely not. We compared that to different inventories. So we went to check what all these people are doing. Air Paris is the official air quality and climate agency of Paris. They published the official number for the city of Paris. We checked what they've done. The blue boxes is the monitoring system. We have a long-term decrease. Good news, 2.5% decrease per year. It's not enough, but it's not far. So they're doing hard, and it seems to be working. The lowest years, 2020 confinement, 2021, this was 2019 here, 2022, God, it's lower than 2020. This year, we emitted less than during COVID. Well, fantastic. Magic, thanks to climate change, transition, action plans? Not exactly, more because we have a European conflict now that totally shifted our way to do emissions. We had a very warm and unusual winter, so we didn't use as much energy as usual. This drop, look at that, happened at the very end of 2022. So you can see the lockdown periods, the emissions are dropping in the different sectors, as I showed you earlier. And you can see that right now, our latest estimate for 2022 is lower than these years where we actually did nothing, went nowhere. So it's kind of interesting to see that the shift in energy can be quick, massive, and rapid. Does it mean it's a good news? Well, it was an unusual warm winter, so this helped a lot. Then we shifted also our energy, and it cost so much that we decided to lower the energy bill. And suddenly, we get it, we decrease. So it's absolutely within our hands. It's not a dream scenario. It's not an impossible goal. You're going to hear that a lot. We're under target. We don't go fast enough. We're moving faster than we imagine, and we can move even faster without changing much in our lifestyle. So don't go COVID style. Go 2022 style. Reduce your bills when you turn on the heat. Use less water. Think when you buy energy for the next round. And this can give you even more decrease than you ever had during a COVID year. Okay, my original topic was about air quality and carbon, and I'm sorry, I'm a carbon guy, so I tend to just be totally biased towards CO2. But I want to show you that sometimes when you draft an air quality plan, it could be incompatible with your carbon emission plan, right? So you have your transport sector or your electricity sector and the residential. On one hand, you have the air quality, is it good or bad, for example? You switch your car to an electrical vehicle. Wonderful, you say carbon decreased. Yes, if your power plant is not running with coal, which is the case, for example, in Germany today. So you need to think even further. When you start to switch your traffic emissions from a car to a power plant, you need to think about what is your power plant. So you have to see that these policies, unless you really have, for example, a renewable energy system to create electricity to put in your new electrical vehicle, now you're tackling both climate change and air quality. When we decide, for example, to change some of the furnace and the way we heat our houses, you can go for gas stove. Well, locally, you might increase your emissions. You can switch to nuclear. Now you're actually decreasing for real your emissions. By the way, France, in the middle of winter, you would be surprised that nuclear cannot make it. We've talked a lot about it in the last winter, but it has been running for a long time. When it's really a cold spell, we go back to coal. We do go back to coal every year because we don't produce enough energy on a cold spell. So you really need to think in two levels, and most of the time, we do not. We absolutely don't. We draft our air quality policies because they're cost efficient and they can directly help your life and improve your health. But we never think about 10 years from now, did you increase your carbon emissions or not? We barely talk to each other, I swear. Why does it matter? Because when you take a city like Baltimore, it goes way further than carbon emissions. Where you have the hotspots in the city of Baltimore, so you see Washington, D.C., and here's the city of Baltimore. Isn't it ridiculous that this is the whole city of Baltimore? That's it. 50 million people live there, but this is the city of Baltimore. The mayor has control on that little chunk. The harbor, one of the largest in the United States, is actually not under the city legislation. So the mayor has no control on the shipping and how it's managed, just to let you know. When you look at the districts, you found out where the emissions are the largest. It's where you have the highways, the industries. This is where you have the poorest neighborhoods, and this is where you have the worst air quality in the entire city. So thinking in all these topics at the same time, improve three ways. You can improve long-term carbon, you can improve actually the air quality of these people, and you can improve their social and daily life. So these are really things we need to think about more carefully, and we haven't done it. Why? Because we have never mapped these CO2 emissions before. The city of France cannot give you the map of their emissions right now. The agency for the east of France can give you a first guess of that, but it's pretty coarse resolution, and they don't know every street corner and every block and buildings. So they cannot really draft a policy in these very fine details because we don't have that information at hand as I'm talking today. Okay, I just want to show you, and I just want now to go back to where the world is going. Urbanization is fast, right now, as we talk. We all remember the end of Second World War, or the downfall of USSR, or the opening of China. We think about all this, but urbanization has never been that fast in the world. There are vast countries that are urbanizing really, really rapidly. China is already slowing down. They have reached already a certain level, and urbanization is now slowing down. Sub-Saharan Africa, next player in the game, they need help, because otherwise they're going to do exactly like we've done 70, 80 years ago. Massive industrialization, massive reliance on the fossil fuel energy, pollution for the first time in several cities in Sub-Saharan Africa has reached maximum levels, like Los Angeles in the 80s. They never had to face that before because there was never enough fossil fuel burnt locally to impact their health. Well, now they're getting there. And if we don't act quickly, it's going to keep growing. These countries are enormous population of very young people who want the industry to develop rapidly. So we really need to think that this system that I'm deploying right now in Paris and Los Angeles and Washington, D.C. are not really the key areas in the world. We have to think how to help them grow because the game is going to be there. The industrialization and the increase in emissions is going to happen there. Our emissions have moved. We are actually outsourcing our services in our industries, and they will be the key role. So we also need to think about how do you install a monitoring network? How do you help them get the information? How do you get them access to the transition, the green funds, and all the support programs we could have to not let them do what we've done 80 years ago, relying on a massive and finite source of energy. I just want to show you what it's looked like to live in Lahore, Pakistan every day. 30 days a year, breathing in Lahore is considered dangerous. Dangerous as in don't step there. Well, they have no choice. Monsoon season is driving that, absolutely, yes. When it rains, good news, it's washing the air, it's cleaning up the atmosphere, the air goes up. But when you're not in the monsoon period, damn. And when I say dangerous, I forget the 30% of the days where you should not even be out. So this is what Lahore looks like today. It's massive, and everything, a lot of things we produce, textile, production, agriculture, they produce rice, they produce wheat. It's the Punjab region, right? So you have a lot of production and industries there. These people are now facing extreme level of pollution that we have never seen before, and they concentrate all the carbon emissions that we don't account for because, good luck, they were not within our political boundaries. So we need to think a little beyond or just local neighborhoods and see that these cities are going to be the key players, and how do we monitor them? Is it going to be satellites? Is it going to be instruments that we deploy in all these cities? We need expertise and we need to act there, maybe not always in Reims, but also where the real action is actually happening in the coming 20 years. Okay, so these are just my key points. But just to say, yeah, don't be fooled. We don't talk to each other. Air quality is not linked with the energy transition. Sometimes we think about it, but when we draft these plans, we do not link them. And we absolutely need to do that. We don't talk to each other because we are two different communities. It's true what I'm saying. For the first time, 6 months ago, I finally went to a meeting where atmospheric chemists were talking. And it's scary for me because I know nothing about chemistry. So we need to open up and think together when we draft the plan, and we are not doing it right now. We need to follow our carbon emissions. We need to track them. We need to monitor them. We need to make sure we are on the trajectory, because if we're not, every year we miss the target, it's another year that we will have to compensate for the years to come. And finally, don't remember, urbanization is not something from the past, it's something from now. At the global level, it's the fastest we have ever seen. And it's really the key player in that transition. We can do as much as we want. We can cut our emissions by 50%. If you don't help these developing economies, we'll never get on target, whatever you do today in your house, at your work, or with people, your activities every day. Thank you for your attention.
Thank you very much for this very nice presentation. Not very optimistic, for sure. I'm surprised, very surprised for the difference in the decrease of emission between the first and second lockdown in 2020. Yes, and as you said, it's not very optimistic because if we stop living right now, it's not sufficient. So I hope you will have some questions. So please raise your hands if you have any questions.
Ça marche? Yes, it works. Thank you, Thomas, for this very nice presentation. Not very optimistic, I agree also. But I'm wondering, I would like to come back to the Paris example. I'm wondering how you can discriminate the contribution of different kind of activities in such small area. Using climate model. I can understand at the scale of a country, of a region, but at the scale of a relatively small city, how can you discriminate between human activity, traffic activity, or different kind of activities?
Yes, that's a great question. This is actually covering a lot of data that we are collecting. Traffic counts, gas consumption, building by building. We go from very detailed and say, do you have a gas burner, an oil burner? Are you electrified or not? How old is your building? How many people are in the building? We count all these details. Then we go for traffic. We ask the city of Paris for some secret information that they cannot share, but they tell us this is the amount of trucks, this is the typical age of a vehicle. So we have these giant tables that we put together. I'm not doing it. It's actually a startup company doing that, and they spend years to collect this data. And they reactualize them every year, so it's a massive amount of work for one city. You're right. It's tremendous, tremendous work.
Yes, good morning. I have a question on the chat from Anthony Lehman, our last speaker this morning. He says, thank you for the very interesting presentation, emphasizing the need for data that we can trust to make decisions. Do you think that we could develop essential pollutants variables, taking examples from essential climate variables?
Oh, I'm not sure I followed the last part. You said...
Hang on, I'm going.
Sorry.
I don't know if you can hear me, but
Oh, yeah.
ask the question.
Yes. Yes, we can hear you. He's
Yeah,
here.
thank you very much.
It's magic.
I was referring to essential climate variables that you probably know of. I don't know if it's a familiar concept to you. It's monitoring what we need to know about climate. And it was developed by this community. And I was wondering if there was effort to do the same for pollutants, to describe and define what are the essential monitoring measures that we should have for pollutants.
Yes, absolutely. Right now we have two different networks, so these variables are measured but not at the same locations. Because when we think about air quality, we want to put the sensors at the street level where people breathe, so human size, height, and we measure these pollutants in a very local approach. So we need to think also how we measure these variables. So now we have co-located air quality stations where we measure CO2. The same inventories can be built for pollutants. They're not yet. We don't have these very high detailed levels of NOx and CO and PM 2.5 and etc. So we have a hard time to link these two. So we need a full inventory able to do the two at the same time. And we need more variables. You're right. Temperature, heat, ion effects, aerosols from biogenic trees. There are a lot of data we're not collecting yet, or we collect them but for different reasons. For example, if you want a map of trees in Paris, you go to talk to the city of Paris because they worry the trees are going to fall on people or on cars. So they keep track of the trees, but not for carbon, not for pollution, just for insurance purposes. So this is very interesting how these variables are collected for many different reasons. So we went on this, Paris did a great initiative called the Open Data Paris Access. And so they put everything free access. We dig into that and it's like gold mines. So we do not even know exactly how many variables we are already collecting to some extent. And I'm still discovering sometimes that I never heard because it was a different service, different department for a different purpose. So absolutely, we need to collect all these variables, link them and try to understand how they could be used and monitored together. Absolutely.
Thanks for the nice talk. I was a bit surprised by how you framed the difference between emission reductions from residential area and traffic. You seem to say that we should rather focus on residential, but I mean, the contributions are quite similar. So I was just wondering why you choose to frame it that way.
Absolutely. So when you measure in the atmosphere, you see everything. You see the trees, the cars, the burn. You don't know what you're looking into. That's why we combine it with the inventory. Up. These kind of products. So then we have mapped very carefully who is where. The wind comes from the west. We know we're targeting this area where there is 30% industry, 44% traffic, etc., etc. The wind turns, we suddenly scan. So we scan rotationally, and we do this kind of triangulation system. We have different towers, so we could see these towers had +2 ppm of CO2, this tower at 1.4, this one has 1.8. Therefore, you have a linear combination of sectors, and you can solve your problem. So we need to have as many points of measurements as we can to cover as much land as we can with different combinations. The other thing you can do is when you measure CO2, you measure NOx as well. Cars emit a lot of NOx. Your house doesn't. It's been optimized, it's been tuned, fine-tuned, and inspected every year. So when we see a huge peaks of NOx, and we can correlate with the peaks of CO2, we can tell if it was more traffic-related or if it was more residential connected. But we're still weak at that. We're not good at it. We are missing a lot of co-emitted species. We don't measure enough gases. We could do much better. So the attribution right now relies a lot on the inventory that people have given to me. And the problem was for a long time we had bad inventory. So you start with a bad inventory and you try to get which sector is doing what. So this game needs to improve. So more species, more cross-correlation, and so you constrain your problem more and more. It's really an optimization problem, if you want to see it in a way.
Another question?
Just a political question. I mean, how the Mayor of Paris reacts to all the data that you have here and how they contribute to...
Ooh, okay. Is it online? What could I say? It's very tricky. We come with these data sets and we're policing them. We're becoming like a tax revenue service. The problem with that is the politicians know that their policies have been drafted on beautiful plans. The Climate Action Plan of Paris has objectives, but nowhere in the document it says what is doing how much. They don't know. They have no estimation. They don't know. When they say, we're going to convert that area into a low carbon, etc., we're going to put more bike lanes, they have no idea exactly the impact of that policy. So they go as they feel, as the money comes, as the voters are happy or not happy. They know their objective is really, really ambitious, and they suspect that they're not on target. So when we came and just said, I'm going to check every neighborhood in Paris and see if you have done your job, you can imagine that they were reluctant to just embrace us and say, sure, install your sensors everywhere. But surprisingly, they help us. They help us deploy our sensors on the rooftops. They are maybe not willing to pay for this program because they worry about the outcome, but they will hear us. So we talk to them every 6 months. We have an update. We try to show them. So far, so good. So they like us. I could tell you the city of France, for example, would be a very different story because it has a magnificent industrial economy that has not been collapsing in the last 20 years, so the emissions tend to just increase. And so is it good or bad? Well, if you think about it and you say, for example, in the newspapers, we talk about Crystal Union, right? A giant sugar factory right there. It looks bad. It looks really bad because when the newspapers make a map of the major emitters in the country, you see that factory next to you. Well, what you don't see is the sugar coming from Brazil. You don't see that. You don't see the boat shipping you this sugar cane, but you see that factory here. So we have to remember that this is what we call direct emissions. They are territorial emissions, and they are unfair. My God, they're unfair. Because if you take your factory, you move it to China, problem solved, and you have achieved your climate objectives. So you need to think in terms of total direct and indirect emissions, but the problem is for the mayors, indirect emissions are out of reach. You cannot control what China is going to do tomorrow. You cannot decide what you're going to buy. If you buy a smartphone, the city is not going to stop you. And so for the city, it's also unfair to judge them and say, success, no success. Oh, bad, your emissions have increased. Well, maybe it's much better to produce sugar right here than to produce it from Brazil. So you have to keep in mind that I don't want to play the blame game because I'm not looking at the full picture of the problem. I'm missing the secret emissions coming from elsewhere. And I don't want to blame the city for that because they have no control over it. So that's why I step on eggs and I don't want to do that blame game. And I would say they do the best they can with the little information they have. Yeah.
Thank you. And just to make the transition, you talk about during monsoon. That is, during monsoon, you have a decrease of emission due to rainfall leaching. So we can wonder if it increases the pollution in soil and shifts the problem, in fact, because you decrease in the atmospheric part. But what is this in the water bodies and soil? So
absolutely. So yeah,
it's a global
wet deposition, and you get that into your soil, and so the atmosphere is clean, but the soil is dirty. Absolutely.
So thank you again for this very nice presentation and the resulting discussion with the audience. So now let's move on. Yes, you can applaud again. So.